There are stars so large that if you replaced our Sun with them, they would swallow the inner planets instantly. There are galaxies so enormous that light itself struggles to cross them within a human civilization's entire recorded history. And then, there are black holes. Not just ordinary black holes, not the kind born from collapsing stars, but monsters, objects so violent, so massive, and so absurdly huge that they stop feeling real the moment you try to imagine them. TON 618 is one of those objects. At first glance, the name sounds forgettable, cold, technical, like some random catalogue number buried inside an astronomy database. But behind that boring label hides one of the largest black holes humanity has ever discovered. A gravitational abyss so extreme that if it replaced the black hole at the centre of our Milky Way, the structure of our solar system would become almost meaningless in comparison. And that's the problem. The human brain is terrible at understanding scale. You hear numbers like 66 billion suns, and your mind accepts it for half a second before collapsing into abstraction. Because what does that actually mean? How big is 66 billion suns? How large is a black hole with a diameter wider than our entire solar system? What would happen if Earth somehow got close to it? How far would its event horizon stretch? Could you orbit it safely? Could it fit inside the Milky Way? And more importantly, how does something this gigantic even exist? Because TON 618 shouldn't feel possible. The universe had no business creating something this enormous, yet somehow it did. Tonight we are going to scale this monster properly, not with vague scientific jargon, not with meaningless giant numbers, but step by step, starting from Earth, then our solar system, then the Milky Way, then the observable universe itself. And by the end of this journey, TON 618 will stop being a name and start becoming a nightmare. Because the deeper you go into extreme black holes, the more terrifying reality becomes, and TON 618 sits near the very top of that list. Chapter 1. The problem with imagining size. Before we even talk about TON 618 itself, we need to address something important. Your brain is lying to you every second. Human beings evolved to understand tiny distances, a few meters, a few kilometers, maybe the size of mountains. That's it. We are not built to comprehend cosmic scale. That's why space documentaries constantly throw giant numbers at you. Millions of kilometers, billions of stars, trillions of miles. But after a certain point, every number starts feeling identical. 1 billion and 1 trillion stop feeling different emotionally. Your brain compresses both into the same category. Really, really big. That's why TON 618 is hard to understand. Because technically, knowing the number behind something is not the same as emotionally understanding it. For example, Earth feels large to us. And honestly, from a human perspective, it is. You could spend your entire life travelling and still never see all of it. The diameter of Earth is about 12,742 kilometres. That sounds huge, but compared to space, Earth is microscopic. You could line up about 109 Earths across the diameter of the Sun, and the Sun itself is considered an extremely average star. Not impressive, not rare, not special, just average. Already the scale starts breaking. Now let's zoom outward. The distance between Earth and the Sun is about 150 million kilometres. Light travels at 300,000 kilometres per second. Even at that speed, sunlight still takes over 8 minutes to reach us. 8 minutes. And that's just inside our local neighbourhood. Now move farther. The outer edge of the solar system sits trillions of kilometres away. Voyager 1, the fastest human-made object ever launched, has been travelling since 1977. Decades. And it still hasn't fully escaped the Sun's gravitational influence. That's how gigantic even our own solar system is. Now imagine something so massive that our entire planetary system starts looking small beside it. That's where TON 618 enters the conversation. But before we scale the monster itself, we need to understand black holes first. Because despite the name, black holes are not cosmic vacuum cleaners randomly sucking things across the universe. That part is wrong. Completely wrong. Black holes obey gravity just like everything else. If the Sun magically became a black hole with the same mass, Earth would not get swallowed. We would continue orbiting almost exactly the same way. The difference is that all the Sun's mass would be compressed into an incredibly tiny region, and that tiny region changes everything. Because black holes are not terrifying simply because they are heavy. They are terrifying because they crush absurd amounts of mass into impossibly small space. That compression creates gravity so intense that eventually not even light can escape. And once light cannot escape, you get the defining boundary of every black hole, the event horizon. Cross it, and there is no return. Not because the black hole suddenly pulls harder, but because space-time itself becomes warped beyond escape. Inside that boundary, every possible future points inward. You do not fall into a black hole the way you fall off a cliff. Instead, the structure of reality forces you toward the center. Space and time themselves betray you. That's what makes black holes so disturbing. They are not just objects sitting inside the universe. They are regions where the normal rules stop behaving normally, and TON 618 pushes those rules to absurd extremes. But first, we need to understand how black holes are born, because TON 618 did not start this large. Nothing in the universe does. Chapter 2. How black holes become monsters. Most black holes begin with death, specifically the death of stars. A star survives because two forces constantly fight each other. Gravity tries to crush the star inward. Meanwhile, nuclear fusion in the core pushes outward. As long as those forces remain balanced, the star survives. But eventually the fuel runs out, and when fusion weakens, gravity wins. For smaller stars like the Sun, the collapse ends relatively gently. But for extremely massive stars, the collapse becomes catastrophic. The core implodes, outer layers explode outward in a supernova, and what remains can collapse into a black hole. These are stellar black holes, usually a few times more massive than the Sun, sometimes dozens, already terrifying, but nowhere near TON 618. Because TON 618 belongs to a completely different category, a supermassive black hole, and astronomers still do not fully understand how these monsters form. That's important. Even modern astrophysics struggles to explain them, because there's a serious problem. The early universe should not have had enough time to build black holes this massive. Yet somehow, when astronomers look deep into space, which also means looking back in time, they find giant black holes appearing absurdly early, almost immediately after the universe formed. That should not happen. Building a supermassive black hole is difficult. Very difficult. You need enormous amounts of matter. You need time. You need sustained growth. And somehow, the universe created these monsters while it was still young. TON 618 is part of that mystery. It is what astronomers call an ultramassive black hole. Not merely supermassive, ultramassive. That distinction matters, because once you cross certain scales, black holes stop behaving the way people imagine them. Smaller black holes are actually deadlier near the edge. That sounds backwards, but it's true. If you fell toward a stellar black hole, tidal forces would rip you apart before you even crossed the event horizon. This process is charmingly named spaghettification. Your feet would experience stronger gravity than your head. Your body stretches, atoms separate, you become a stream of matter, a horrific death. But supermassive black holes behave differently, because their event horizons are vastly larger. The tidal forces at the edge can actually be weaker. In theory, you could cross the event horizon of an enormous black hole without immediately noticing, which is somehow even more disturbing. You would pass the point of no return peacefully, quietly, without realizing you were already doomed. TON 618 belongs in that category. Its event horizon is so enormous that the edge itself is relatively calm, at least compared to smaller black holes. That calmness is deceptive, because once you go deeper, escape becomes fundamentally impossible. Not difficult, impossible. And the scale of this thing is beyond ridiculous. To understand just how absurd it is, we need to start measuring. Properly. Not with meaningless numbers, but with comparisons that break the mind slowly. So let's begin somewhere familiar. The Sun. The Sun contains 99.8% of all the mass in our solar system. Every planet combined is almost irrelevant compared to it. Jupiter, Saturn, Earth, Mars, together they barely matter. The Sun dominates everything gravitationally. Now imagine multiplying the Sun's mass 66 billion times. That is roughly the estimated mass of TON 618. 66 billion suns. Pause for a second, because this is where comprehension starts failing. Our galaxy contains hundreds of billions of stars. TON 618 alone rivals the mass of entire galactic structures, not stars, galaxies. and yet it is compressed into a single gravitational system, a single black hole. That's insane. But mass alone still does not communicate the scale emotionally, so let's talk about size. If TON 618 replaced the Sun at the centre of our solar system, the event horizon would extend far beyond the orbit of Neptune. Not the black hole itself, the event horizon, the boundary beyond which escape becomes impossible. Neptune orbits the Sun at roughly 4.5 billion kilometres away. TON 618's event horizon diameter is estimated at over 390 billion kilometres. That is not a typo. 390 billion kilometres. At that scale, our solar system stops feeling large, it becomes decorative, and this is where the horror begins, because black holes are mostly empty space. That sounds impossible, but it's true. TON 618 is so large that if you averaged its density across its volume, it would actually be less dense than air. Think about how absurd that is. An object capable of trapping light itself, less dense than Earth's atmosphere, not because it's weak, but because it is unimaginably enormous. The larger a black hole becomes, the lower its average density can get. That fact alone feels like science fiction. But reality does not care whether something feels intuitive. TON 618 exists anyway, and it sits billions of light years away, silently dominating its region of space. Which raises another question. How did we even find it? Because black holes do not emit light. So how do astronomers detect something literally invisible? The answer reveals another terrifying aspect of TON 618. It is not just enormous, it is feeding aggressively. Chapter 3. The quasar that hid a monster. TON 618 was not originally famous because astronomers thought it was a black hole. At first, they believed it was a star. That's actually where the name comes from. TON refers to the Tonantzintla Observatory in Mexico, where the object was catalogued. 618 was simply its number. Nothing dramatic, nothing legendary, just another object in the sky. But later observations revealed something shocking. TON 618 was not a star. It was a quasar, and quasars are among the brightest objects in the entire universe. That sounds strange at first. How can a black hole, an object famous for trapping light, become associated with something unbelievably bright? Because the brightness does not come from the black hole itself. It comes from the destruction happening around it. When matter falls toward a black hole, it rarely drops straight in. Instead, it forms an accretion disk. A spiraling disk of gas, dust, plasma, and debris rotating at incredible speeds. Friction inside the disk becomes extreme. Temperatures rise into the millions of degrees. Matter heats up so violently that it emits enormous amounts of radiation, sometimes more than entire galaxies. That is a quasar, a feeding supermassive black hole so active that the surrounding chaos outshines billions of stars. TON 618 is one of the brightest quasars ever discovered, which means the black hole at its centre is consuming staggering amounts of matter. Imagine entire stars being torn apart, gas clouds larger than solar systems spiralling inward, matter accelerating close to the speed of light, all disappearing forever. And the energy released during that process becomes visible across billions of light years. That's how astronomers detected TON 618. Not because they saw the black hole, but because they saw the violence surrounding it, and that violence is difficult to exaggerate. TON 618 emits luminosity estimated at tens of trillions of times brighter than the Sun. Again, the numbers stop feeling real. The Milky Way contains hundreds of billions of stars, yet this single active galactic nucleus can rival entire galaxies in brightness. That should tell you how extreme the environment is near the black hole, and yet despite all that power, the actual event horizon remains dark, invisible. A perfectly black boundary sitting beneath the brightest inferno in the cosmos. That contrast is almost poetic. Absolute darkness surrounded by catastrophic light. But there is something even stranger about TON 618. Its age. When we observe TON 618, we are seeing it as it existed over 10 billion years ago. The light reaching Earth today began its journey long before the Sun even formed, long before Earth existed, long before humans, civilization, history, everything we have ever known. That means TON 618 became monstrous extremely early in cosmic history. which deepens the mystery of how these black holes grow, because standard growth models struggle to explain such rapid expansion. Some theories suggest early black holes formed from direct collapses of enormous primordial gas clouds. Others propose runaway mergers. Others speculate about exotic conditions in the infant universe. But the honest answer is this: we still do not fully know, and that uncertainty matters, because every time astronomy discovers something like TON 618, it exposes cracks in our understanding of the universe. The cosmos keeps creating objects larger, earlier, and more extreme than expected. And black holes are often where those surprises appear, especially giant ones. But even now, after all these comparisons, you probably still don't emotionally understand how huge TON 618 is. That's normal. So let's try something different. Let's shrink ourselves. Imagine you're inside a spaceship approaching TON 618. Not at faster than light speeds, not magically, realistically. What would you actually see? What would happen as you got closer? And how long would it take before the scale finally became impossible to ignore? The answer is unsettling, because you could approach TON 618 for an incredibly long time and still not realize how close you are. Chapter 4: Flying Toward. TON 618. Space is deceptive. There are no streetlights, no atmospheric haze, no familiar objects to compare against. Without reference points, size becomes almost impossible to judge. That's why astronauts describe space as strangely disorienting, and that effect becomes extreme near gigantic black holes. If you travelled toward TON 618, the first thing you would notice is not the black hole itself. It would be the accretion disk, an enormous rotating structure of superheated matter glowing with terrifying intensity. The disk would dominate your vision long before the event horizon became visible, and visible is almost the wrong word. Black holes are not objects you see directly. You see the distortion around them. TON 618 would bend light so severely that stars behind it would appear warped and smeared across spacetime. The black hole would look less like a sphere and more like a wound in reality, a perfectly dark region surrounded by twisted light. Gravitational lensing would distort the universe itself. Entire star fields would curve around the black hole. Light paths would bend into impossible shapes. The cosmos would appear broken. And here is the truly terrifying part. You still would not be close. TON 618 is so gigantic that distance loses meaning around it. You could travel for days toward the event horizon at incredible speed and still remain outside. That's because the event horizon itself spans hundreds of billions of kilometers. Let's make this more concrete. The distance from the Sun to Pluto averages around 5.9 billion kilometers. TON 618's event horizon diameter is vastly larger than that. Our entire planetary system would disappear inside it. Not near the center, inside the edge. Imagine standing on Earth and realizing every planet, asteroid, comet, and spacecraft in the solar system already exists within the black hole's boundary. That's the scale we're discussing, and because the event horizon is so large, the gravitational gradient near the edge becomes surprisingly gentle. You would not immediately die crossing it. There would be no dramatic wall, no explosion, no sudden impact. If you ignored the radiation from the accretion disk and somehow survived the environment, crossing the event horizon itself might feel almost uneventful, which is horrifying. You would pass the point of no return without any physical barrier stopping you. From your perspective, things could seem normal for a while, but outside observers would see something entirely different. According to relativity, time near a black hole slows dramatically. The closer you get, the more severe the effect becomes. To distant observers, you would appear to slow down near the horizon. Your signals would redshift, fade. Eventually, you would seem frozen near the edge forever, never quite crossing. Meanwhile, from your own perspective, time continues normally. You cross inward, and eventually, no possible path leads back out. This is why black holes are not just giant objects. They are consequences of general relativity taken to the limit. TON 618 represents spacetime distorted on almost unimaginable scales. And yet even this giant is not infinite. That's another misconception. Black holes are enormous, but they are still finite structures inside a larger universe. In fact, if you compare TON 618 to galaxies, it begins shrinking again. That's how insane cosmic hierarchy becomes. TON 618 can swallow solar systems. Yet galaxies can contain hundreds of billions of stars spread across unimaginable distances. The Milky Way itself is roughly 100,000 light-years wide. TON 618's event horizon, massive as it is, measures only a fraction of a light-year across. Already the scale flips again. The monster becomes small compared to galactic dimensions, and that reveals one of the deepest truths about the universe. Everything is relative. Earth feels huge until compared to the Sun. The Sun feels gigantic until compared to black holes. Black holes feel monstrous until compared to galaxies. Galaxies feel enormous until compared to galaxy clusters, and galaxy clusters become tiny against the observable universe. Every level destroys the importance of the previous one. That endless ladder of scale is one of the reasons astronomy feels existential. It constantly reminds us that human intuition was never designed for reality. But TON 618 still occupies a special category. Because even among supermassive black holes, it is extraordinarily large. To understand just how extreme it really is, we need comparisons. A lot of them. And the first comparison starts with the black hole at the centre of our own galaxy, Sagittarius A star. Chapter 5, TON 618 versus Sagittarius A star. At the centre of the Milky Way sits a supermassive black hole called Sagittarius A star. Astronomers usually shorten it to SGR A star. This black hole is enormous by normal standards. Its mass equals roughly 4 million suns. That sounds absurdly huge, and it is. If Sagittarius A star replaced the Sun, its event horizon would stretch millions of kilometres across. Mercury would disappear instantly. The inner solar system would be transformed. Humanity would be finished. And yet, compared to TON 618, Sagittarius A star is tiny. Not smaller, tiny. TON 618 outweighs Sagittarius A star by a factor of roughly 16,000. Think about that. The monstrous black hole anchoring our entire galaxy would look insignificant beside TON 618. This comparison matters because Sagittarius A star already dominates the Milky Way's centre. Stars orbit around it at incredible speeds, some complete orbits in just years despite travelling across enormous distances. The gravity there is overwhelming, and yet TON 618 exists on another level entirely. If Sagittarius A star were reduced to the size of a coin, TON 618 would become a skyscraper. That's the scale difference. Now imagine placing TON 618 at the centre of our galaxy. The night sky would change dramatically. The black hole itself would not glow. But the accretion disk could outshine vast regions of the Milky Way. Radiation from nearby matter would become catastrophic. Entire stellar systems near the centre could be disrupted. The galactic core would transform into a violent quasar-like environment. Life on Earth might not survive depending on activity levels, and if Earth somehow orbited safely at our current distance, the black hole would still appear horrifyingly dominant in the sky through telescopes. But perhaps the most disturbing realization comes from orbital mechanics. You can orbit black holes safely if you remain far enough away. That sounds counterintuitive. Movies often portray black holes as unavoidable death traps, but gravity obeys distance. If TON 618 replaced the Sun while somehow keeping the same mass distribution effects at Earth's distance, our orbit could theoretically continue. The problem would be the missing sunlight, not immediate gravitational destruction. This is one of the most misunderstood facts about black holes. They are dangerous up close, not magically across infinite distances. Still, up close becomes a very different concept with TON 618, because its gravitational influence extends across colossal scales, and near the centre, orbital speeds become extreme. Matter in the accretion disk circles at significant fractions of light speed. Friction generates extraordinary heat. Magnetic fields twist violently. Jets of radiation can erupt outward across intergalactic distances. Some quasars launch relativistic jets spanning hundreds of thousands of light years, essentially cosmic flamethrowers powered by gravity itself. TON 618 may have produced similarly colossal structures in the past. That idea alone is terrifying. A black hole capable of influencing space across scales larger than entire galaxies. And this raises another uncomfortable question. What is the upper limit? Can black holes become infinitely large? Could something bigger than TON 618 exist? The answer is yes, possibly, and that realization changes the entire discussion. Because TON 618 may not even be the final boss of black holes, it may simply be one of the largest we have found so far, which means the universe could still be hiding even worse monsters. Chapter 6. Could anything be bigger? Astronomy has a habit of humiliating certainty. Every time humans think we understand the limits of the universe, reality produces something larger, hotter, older, more energetic, more impossible. TON 618 is currently considered one of the largest known black holes, but the key word there is known. The observable universe contains hundreds of billions of galaxies, possibly trillions, and each galaxy may contain a supermassive black hole at its center. That means there could be countless ultramassive black holes scattered across the cosmos. Many are likely too distant or inactive for us to detect easily. Others may hide in regions obscured by dust and gas. Some may simply not point enough radiation toward Earth for us to notice. In other words, TON 618 may be extraordinary, but not unique. And that is a deeply unsettling possibility, because even at its current estimated size, TON 618 already stretches the boundaries of theoretical understanding. If significantly larger black holes exist, astrophysics faces an even bigger puzzle. How do these things grow so quickly? One possibility involves mergers. Galaxies collide constantly over cosmic timescales. When they merge, their central black holes can eventually spiral together and combine. Over billions of years, repeated mergers could create larger and larger black holes. But there are limits. Accretion rates matter, radiation pressure matters, time matters, and despite all those constraints, the universe still managed to create monsters like TON 618 extremely early. That suggests black hole growth in the early universe may have been far more aggressive than expected. Some scientists even speculate about primordial black holes formed shortly after the Big Bang. These hypothetical objects could have acted as seeds for later giants. Others investigate direct collapse black holes, massive gas clouds collapsing almost immediately into giant black hole seeds without forming normal stars first. The problem is that every explanation comes with uncertainties, and until we understand the origin of ultramassive black holes properly, TON 618 remains partly mysterious. But perhaps the strangest aspect of all this is psychological, because once you truly grasp the scale of objects like TON 618, your perspective changes. Human conflicts start feeling microscopic, cities feel temporary, civilizations feel fragile, history itself begins shrinking. TON 618 existed long before Earth formed. The light reaching us today began travelling across space before humanity existed, and long after our species disappears, the black hole may still remain. That kind of timescale is difficult to emotionally survive. The universe is not merely large, it is ancient beyond intuition, and black holes are among the few objects capable of outliving almost everything else. Stars die, galaxies evolve, civilizations vanish, but giant black holes can persist for unimaginable stretches of time. In the far future of the cosmos, after stars stop forming and galaxies fade into darkness, black holes may dominate the universe. TON 618 could continue existing, while almost every familiar structure disappears. That future has a name: the Degenerate Era, an epoch where stellar activity ends and the universe becomes cold, dark, and sparse. Eventually, even black holes evaporate through Hawking radiation. But for giants like TON 618, that process takes incomprehensible amounts of time. Not millions, not billions. Numbers so enormous that human language stops functioning properly. A black hole this massive could survive for around 10 to the power of 100 years or more. That number is so absurd it barely qualifies as meaningful. For comparison, the current age of the universe is only about 13.8 billion years. TON 618's eventual evaporation timescale makes the entire current universe feel like an instant, and that may be the most terrifying fact of all. Not the size, not the gravity, not the event horizon, but the duration. The sheer persistence of these monsters. Black holes feel eternal because compared to human existence, they practically are. And TON 618 sits among the most enduring structures we know, a colossal scar in spacetime that may outlive galaxies themselves. Which brings us to a disturbing realization. TON 618 is not simply a giant object, it is a preview, a glimpse of what the universe becomes when gravity wins completely. And in the next part of this journey, we are going deeper. because understanding TON 618's size is only the beginning. Next, we will explore what would actually happen if you approach the event horizon. What time dilation near a monster like this truly means, whether you could survive orbiting it, how black holes distort causality itself, and why the singularity at the centre may represent one of the greatest failures in modern physics, because once you stare into objects like TON 618 long enough, the universe starts revealing something uncomfortable. Reality may be far stranger than we are prepared to handle, and TON 618 is one of the clearest warnings we have ever found. Chapter 7. What if? TON 618 replaced the Sun. This is the comparison everyone eventually wants to make. What would actually happen if TON 618 suddenly appeared where the Sun is right now? Not near Earth, not passing through the solar system, directly replacing the Sun itself. The answer is both less dramatic and far more horrifying than most people expect. The first thing to understand is that gravity depends on mass and distance, not physical size. If the Sun were magically replaced by a black hole with exactly the same mass, Earth would continue orbiting normally. The orbit would barely change. We would freeze to death because sunlight disappears, but gravitationally the solar system would remain mostly stable. TON 618 changes that completely. Because TON 618 does not merely match the Sun's mass, it outweighs it by tens of billions of times. The entire structure of the solar system would become irrelevant almost instantly. Mercury would not exist anymore. Venus would not exist anymore. Earth would not exist anymore. Mars, Jupiter, Saturn, Uranus, Neptune, all gone. And not because the planets would immediately collide with a black hole. Most would already be inside the event horizon. That is the detail people struggle to emotionally process. The event horizon itself would stretch far beyond the orbit of the outer planets. Neptune averages around 4.5 billion kilometers from the Sun. TON 618's event horizon radius is vastly larger than that. Every planet would effectively begin inside the point of no return. Humanity would already be doomed before even understanding what happened. There would be no escaping outward, no rockets, no emergency evacuation, no warning. Once the event horizon surrounds you, every future path leads inward. That statement sounds abstract until you understand what general relativity actually implies. Inside the event horizon, the singularity becomes part of your future the same way tomorrow normally is. You cannot avoid it any more than you can avoid moving forward through time. That's the terrifying reality of black holes. They do not merely trap you physically, they trap causality itself. And TON 618's event horizon is so enormous that the entire architecture of our planetary system disappears within it. But let's imagine something slightly different. Suppose Earth somehow remained outside the event horizon. Suppose we were placed safely farther away. What would TON 618 look like in the sky? The answer depends heavily on whether it is actively feeding. A quiet black hole is difficult to see directly. You would mostly notice gravitational lensing. Stars bending around darkness, light curving, unnaturally. But an active TON 618 would transform the sky into something catastrophic. Its accretion disk could become brighter than anything humanity has ever witnessed. The radiation output alone could sterilize nearby planetary systems. X-rays, gamma rays, relativistic particles. The environment around quasars is unbelievably hostile. Even at safe orbital distances, life could become impossible. And then there are the jets. Some supermassive black holes launch twin beams of matter and radiation from their poles. These jets can extend across enormous fractions of intergalactic space. They are powered by magnetic fields interacting with rotating spacetime itself. Think about how absurd that sentence is. Rotating spacetime. Black holes are so extreme that Einstein's equations predict they can literally drag spacetime around with them. This effect is called frame dragging. Near rapidly rotating black holes, spacetime behaves almost like a twisted fluid. TON 618 may rotate incredibly fast. Many giant black holes do. And if that is true, the surrounding environment becomes even more violent. Matter spiraling inward accelerates to extraordinary speeds. Energy extraction mechanisms become more efficient. Jets become more powerful. The black hole effectively turns gravity into an engine, and yet despite all this violence, the actual center remains hidden forever. No information escapes from within the event horizon, which creates one of the greatest paradoxes in physics, because according to quantum mechanics, information should never truly disappear. But black holes seem capable of erasing it. This conflict between relativity and quantum theory sits at the center of modern theoretical physics. And giant black holes like TON 618 are where those contradictions become impossible to ignore. The universe is giving us two theories that both work incredibly well, but refuse to cooperate fully. General relativity explains gravity beautifully. Quantum mechanics explains microscopic reality beautifully. But at singularities, both frameworks break, and TON 618 contains one of the largest singularities we know, which raises another disturbing possibility. What if singularities are not real? Some physicists believe the singularity simply marks the point where our mathematics fails, an indicator that our understanding is incomplete, because infinities in physics are usually warning signs. They often mean a theory has reached its limits. Inside TON 618, density and curvature theoretically become infinite, but nature may not actually allow true infinities. Instead, some deeper structure may exist beneath our current models: quantum gravity, string theory, loop quantum gravity, unknown physics, something. At the moment, nobody knows, and that uncertainty becomes strangely emotional when discussing black holes, because black holes represent places where human knowledge literally stops, not metaphorically, literally. There is a boundary beyond which we cannot retrieve information, a wall in reality. TON 618 contains a region permanently disconnected from the rest of the observable universe. That idea feels almost supernatural, but it emerges naturally from mathematics, and mathematics has been brutally reliable in astronomy. Again and again, equations predict bizarre objects long before humans observe them. Black holes themselves were once controversial. Einstein disliked aspects of the idea. Many scientists doubted nature could truly create them. Then evidence accumulated, then observations improved, then gravitational waves were detected from black hole mergers, then humanity photographed the shadow of a black hole itself. Reality kept confirming the impossible, which means when modern physics predicts bizarre things near TON 618, we should probably pay attention, because the universe has a long history of being far stranger than human intuition allows, and perhaps nowhere is that clearer than in the relationship between time and black holes, because near TON 618, time itself starts behaving like a distorted landscape. Chapter 8. The black hole that breaks time. When most people imagine black holes, they think about gravity, compression, darkness, destruction. But gravity and time are deeply connected. That was one of Einstein's greatest discoveries. Massive objects do not merely pull on matter, they warp spacetime itself, and the stronger gravity becomes, the slower time passes. This is not science fiction, it has been as experimentally verified countless times. Even Earth slightly distorts time. GPS satellites must account for relativistic effects, or navigation systems would fail. Time literally passes differently depending on gravity and velocity. Near black holes, these effects become extreme, and near TON 618, they become almost unimaginable. Suppose you had a spaceship powerful enough to orbit safely near the event horizon. From your perspective inside the ship, time would feel normal. Your heartbeat remains steady. Your thoughts continue naturally. Nothing feels strange locally. But distant observers would see your clock slowing dramatically. Hours for you might equal years elsewhere. Days might equal centuries. This means black holes effectively become time machines into the future, not the past. The future. If you approached close enough to TON 618 and somehow survived, you could theoretically witness enormous spans of external cosmic evolution while experiencing relatively little personal time. Civilizations could rise and disappear, stars could die, galaxies could evolve. Meanwhile, your local experience remains comparatively short. The movie Interstellar popularized this idea using the black hole Gargantua. But TON 618 dwarfs Gargantua in scale. The relativistic effects near an ultra-massive rotating black hole could become astonishing. And here's where things become philosophically disturbing. From certain perspectives, black holes blur the distinction between space and time. Outside the event horizon, you can move through space in different directions freely. But once you cross the horizon, moving toward the singularity becomes as unavoidable as moving toward tomorrow. The geometry of space-time changes fundamentally. That statement is difficult to visualize because human brains evolved in weak gravitational environments. We assume time flows universally. It does not. TON 618 exposes that illusion brutally. Near extreme gravity, reality behaves differently, and the deeper physicists investigate these environments, the more uncomfortable the implications become. Some solutions to Einstein's equations even suggest theoretical possibilities like wormholes or closed time-like curves. Most likely these structures cannot remain stable naturally, but the fact that the equations allow them at all reveals how bizarre spacetime becomes near gravitational extremes. TON 618 represents one of the most extreme known distortions in the observable universe, a place where gravity dominates so completely that normal intuition fails entirely. And still, despite all its power, TON 618 obeys deeper cosmic rules. Even giants eventually die. That might sound impossible. How could something this enormous ever disappear? But according to Stephen Hawking, black holes slowly evaporate. Quantum effects near the event horizon allow tiny amounts of energy to escape. Over incomprehensibly long periods, black holes lose mass. Small black holes evaporate faster. Huge black holes evaporate absurdly slowly. TON 618's lifespan is so colossal that the current age of the universe becomes effectively meaningless by comparison. Imagine writing the universe's entire 13.8 billion year history on a single page. TON 618's future lifespan would require more pages than humanity could ever physically produce. That is not poetic exaggeration. The numbers genuinely become absurd beyond language, which means TON 618 may survive into epochs where no stars remain. No sunlight, no galaxies visible nearby, only darkness, and scattered black holes drifting through an aging cosmos. In that distant future, TON 618 could become one of the final surviving structures in existence, a silent gravitational monument persisting while almost everything else fades away. That image changes the emotional tone of black holes completely. They stop feeling like temporary cosmic disasters. Instead, they begin resembling the universe's long-term end state, gravity winning slowly over unimaginable spans of time. And the fact that we exist early enough in cosmic history to observe active stars, galaxies, and quasars may actually make our era unusually vibrant. TON 618 is terrifying, partly because it hints at that future. A future where darkness dominates, where matter decays, where black holes become kings of a dying universe, and yet somehow, despite all this cosmic horror, there is still beauty in it. Because objects like TON 618 reveal the universe at its most honest. No comforting, illusions, no human-centered perspective, just physics operating at scales beyond emotion. And perhaps that is why black holes fascinate us so deeply. They force humanity to confront reality stripped of familiarity. TON 618 does not care about civilization. It does not care about history. It does not care about life. It simply exists. A gigantic consequence of gravity and time. A structure so large that our solar system vanishes inside its shadow, and somewhere, billions of light years away, it continues feeding in darkness, while the light from its ancient violence still races toward Earth. That alone is enough to make the universe feel terrifyingly alive. Chapter 9. Falling into TON 618. There is a strange misconception about black holes. Most people imagine them like giant cosmic vacuum cleaners. You drift too close, you get sucked in instantly, everything ends violently. But reality is far more disturbing, especially with an ultra-massive black hole like TON 618. Because the larger the black hole becomes, the stranger the experience of falling into it actually is. If you approached a small stellar black hole, tidal forces would destroy you long before reaching the event horizon. Your body would stretch atom by atom, bones separate, cells tear apart, matter becomes a stream. Spaghettification, a ridiculous name for a horrifying process. But TON 618 changes the scale so dramatically that the event horizon itself becomes comparatively gentle. That sounds impossible. How can a black hole large enough to swallow solar systems become less violent at the edge? Because tidal forces depend on how quickly gravity changes across distance. Small black holes compress their gravity into smaller regions. The difference in gravitational pull between your feet and your head becomes extreme. Large black holes spread that curvature across vastly larger distances. So ironically, TON 618 could allow you to cross the event horizon alive, at least temporarily. That is one of the most psychologically terrifying facts in astrophysics. You would not slam into a wall, you would not bounce off an invisible barrier, you would simply continue inward. And at first, almost nothing feels different. Imagine that carefully. You are crossing the point where escape from the universe becomes impossible, and your body may not even notice immediately. The stars behind you still shine, your ship still hums, your heartbeat continues, yet every future path now points toward destruction. That is what the event horizon truly means, not a physical surface, a geometric prison. Once inside, space-time itself tilts inward, and because TON 618 is so large, this prison becomes enormous. If the Sun became TON 618, Earth would already begin inside the event horizon. So now imagine falling inward from somewhere near the outer edge. How long would it take before reaching the singularity? The answer depends on trajectory, rotation, and relativistic effects. But unlike tiny black holes, where destruction comes rapidly, ultramassive black holes can provide surprisingly long inward journeys. You could theoretically survive for hours, maybe longer. That idea alone feels cursed, because during that fall, you would witness the universe behaving in ways human intuition cannot process. Light from outside space would distort. The visible universe could compress into warped patterns around you. Radiation intensifies. Time dilation grows stronger, and eventually the geometry of space-time itself becomes impossible to navigate. There is another terrifying detail people rarely discuss. Inside the event horizon, you cannot stop moving inward, not with rockets, not with infinite fuel, not with perfect technology. This is important. Many people think escaping a black hole is just a matter of going faster. It is not. Inside the event horizon, escape would require moving faster than light, and according to everything we understand about physics, that cannot happen. The singularity becomes unavoidable, a destination woven into causality itself. Imagine a river flowing toward a waterfall. Outside the horizon, your ship can still outrun the current, but beyond a certain point, the river moves faster than any possible boat. No matter how powerful your engines become, every path leads over the edge. That is life inside a black hole. Now multiply that reality across a structure hundreds of billions of kilometers wide. TON 618 is not merely dangerous. It is an entire region where normal physics stops offering freedom. And yet the true horror may lie deeper, because the singularity at the center represents one of the biggest unsolved problems in science. According to general relativity, matter collapses infinitely. Density becomes infinite. Space-time curvature becomes infinite. But infinities in physics usually mean something has gone wrong. They often signal the breakdown of a theory. Most physicists suspect singularities are not truly physical objects. Instead, they may represent places where our understanding fails completely. TON 618 therefore contains something profoundly mysterious. Not merely an object, a boundary of knowledge, a place where modern physics dissolves, and somehow humanity managed to discover it from billions of light years away. That fact alone is extraordinary. Tiny biological creatures on a small rocky planet inferred the existence of one of the largest known black holes in the universe by studying light, mathematics, gravity, patterns. It is one of the greatest achievements in scientific history. But the more we learn about black holes, the more uncomfortable reality becomes, because eventually you encounter the information paradox, and once you understand that paradox, black holes stop being merely giant cosmic objects. They become direct attacks on the foundations of physics. Chapter 10. The Black Hole. Information Paradox. Black holes are where the two greatest theories in modern science begin fighting each other. General relativity and quantum mechanics. Both are extraordinarily successful. Both predict reality with incredible accuracy, and both become deeply incompatible near singularities. That conflict creates one of the biggest mysteries in all of physics, the black hole information paradox. To understand why this matters, we need to define information carefully. In physics, information does not simply mean words or memories. It refers to the complete physical description of a system, particles, states, properties, quantum configurations. According to quantum mechanics, information cannot truly be destroyed, ever. The universe evolves predictably through quantum rules. Information may become scrambled, dispersed, practically impossible to reconstruct, but not fundamentally erased. Black holes seem to violate that principle. Imagine throwing an encyclopedia into TON 618, then throw in a planet, then stars, then entire civilizations. From the outside perspective, all that information disappears beyond the event horizon. Eventually, if Hawking radiation is correct, the black hole itself slowly evaporates. So what happens to the information? Does it vanish forever? If yes, quantum mechanics breaks. If no, then somehow the information must survive. But how? This question has haunted theoretical physics for decades. Stephen Hawking originally argued information is destroyed. Later, he changed his mind. Other physicists proposed holographic principles, quantum encoding on event horizons, exotic correlations, firewall hypotheses. Entire careers emerge from this single problem, and giant black holes like TON 618 sit at the center of the debate. Because the larger the black hole becomes, the more bizarre the implications grow. Some theories suggest information is encoded across the event horizon, like a two-dimensional projection. Others suggest spacetime itself emerges from quantum entanglement. That idea sounds insane, but modern theoretical physics increasingly points towards something deeply strange. Space and time may not be fundamental. They may emerge from deeper informational structures. If that sounds difficult to visualize, that's because it is. Human brains evolved for survival on African savannas, not for understanding quantum gravity. Yet somehow mathematics keeps dragging us toward increasingly alien descriptions of reality. TON 618 exists at the crossroads of those mysteries, an object so extreme that our best theories begin malfunctioning near it. That is why black holes fascinate physicists so deeply. They are not merely astronomical objects, they are laboratories for the limits of reality. Every major unsolved question eventually circles back to black holes. What is space-time? What happens to information? Can gravity become quantum? Are singularities real? How does the universe behave at its deepest level? TON 618 does not answer these questions. It intensifies them. And perhaps the strangest part is this. Black holes were once considered mathematical, curiosities. Now they may hold the key to fundamental physics. Reality has a habit of hiding its deepest secrets inside the most extreme objects, and TON 618 ranks among the most extreme known. But despite all the terrifying mathematics, there is another question people keep asking. Could humanity ever actually use a black hole? Could a civilization harness something like TON 618? At first, the idea sounds absurd, but some physicists take it surprisingly seriously. Because black holes are not just destroyers. Under certain conditions, they are also extraordinary energy sources. Chapter 11. Could a civilization use TON 618? Advanced civilizations in science fiction often harvest stars, build megastructures, manipulate galaxies. But eventually, if a civilization survives long enough, black holes become unavoidable. Because black holes are unbelievably efficient energy systems. Matter falling into them converts mass into energy with astonishing effectiveness, far more efficient than nuclear fusion. In some cases, rotating black holes may convert around 40% of infalling matter into usable energy. Fusion inside stars converts less than 1%. That difference is enormous. TON 618 therefore represents a potential energy source beyond anything humanity currently understands technologically. An advanced civilization might theoretically build structures orbiting safely around the accretion disk, harvest radiation, extract rotational energy, use gravitational effects for computation, perhaps even manipulate relativistic time dilation strategically. The famous Penrose process suggests rotating black holes can lose rotational energy under specific conditions. Essentially, space-time itself becomes part of the engine. Imagine building technology around warped reality. That sounds like fantasy, yet the equations permit it. Some physicists have even speculated that black holes may become ideal computers, the ultimate processing systems. Others wonder whether extremely advanced civilizations might migrate toward black holes in the distant future of the universe. Why? Because black holes persist longer than stars. In a dying cosmos, they may become the final stable energy reservoirs available. That idea changes the emotional image of black holes entirely. Instead of viewing them only as cosmic predators, they become possible anchors for future intelligence. TON 618, with its enormous lifespan and energy output, could theoretically support unimaginable engineering projects. Of course, for humanity, this remains pure speculation. We are nowhere near capable of such feats. We struggle to return humans safely to the moon. Harnessing ultramassive black holes belongs to civilizations vastly beyond ours, but thinking about those possibilities reveals something important. TON 618 is not merely an object. It is an environment, a gigantic astrophysical system with complex dynamics, accretion flows, magnetic turbulence, radiation fields, orbital mechanics, relativistic jets, warped spacetime, and inside all of that sits an invisible boundary from which no information escapes. The sheer scale of the system becomes difficult to emotionally process. You could fit countless solar systems within regions surrounding TON 618. Entire civilizations could theoretically orbit safely at immense distances while still remaining inside its broader gravitational influence. And yet even with all that scale, TON 618 remains tiny compared to the observable universe. That hierarchy never stops. Every giant structure shrinks against something larger, which brings us to another terrifying realization. If TON 618 feels impossible, what about the largest structures in existence? Because the universe contains formations so vast that even galaxies become microscopic components inside them. And once you compare TON 618 to those structures, the black hole begins shrinking again. Chapter 12. TON 618 versus the cosmic web. Human beings instinctively think in isolated objects. Planets, stars, galaxies. But on the largest scales, the universe resembles a network. A gigantic cosmic web. Galaxies are not randomly scattered through space. They cluster along enormous filaments stretching across hundreds of millions of light years. Between those filaments lie gigantic voids, regions with comparatively little matter. The observable universe therefore resembles a kind of three-dimensional neural network, an unimaginably large structure formed by gravity over billions of years, and within this cosmic web sit galaxy clusters. Superclusters, structures so large that light itself requires immense spans of time to cross them. Compared to these formations, even TON 618 starts shrinking. That is one of the most emotionally destabilizing aspects of astronomy. No matter how gigantic something appears, the universe always contains a larger context. TON 618 can swallow solar systems, yet galaxies contain hundreds of billions of stars. Galaxy clusters contain thousands of galaxies. Superclusters contain countless clusters, and all of them form only tiny threads inside the observable universe. This hierarchy matters because it changes how we emotionally interpret scale. TON 618 feels like a final boss, an ultimate monster. But cosmically speaking, it is still just one component inside a far larger architecture. A gigantic node inside an even bigger universe. That realization can feel strangely humbling, or terrifying, depending on perspective. Because it reminds us that the universe is under no obligation to feel human-sized. Reality operates on scales completely detached from biological intuition. The observable universe spans roughly 93 billion light-years in diameter. That number alone barely means anything emotionally. Human brains cannot picture it. But somewhere inside that incomprehensible volume, TON 618 exists as a single dark object among trillions of others. And that perspective creates another disturbing question. Could there be black holes even larger than TON 618, hidden somewhere in the cosmic web? The honest answer is yes, possibly many. Astronomy only observes a fraction of the universe clearly. Distance limits us. Light travel time limits us. Dust obscures regions. Inactive black holes remain difficult to detect. TON 618 became visible largely because it was feeding aggressively. Quiet giants could remain hidden far more easily. Some may lurk in distant galaxies, dormant and invisible. Others may have existed in the early universe and since evolved differently. The cosmos is simply too large for certainty. That uncertainty matters, because it means TON 618 may represent only the beginning of what nature can create. And if the universe can naturally produce black holes this large, then reality may allow structures even more extreme than our current theories comfortably predict. Astronomy repeatedly teaches the same lesson. Never assume you've seen the limit. The universe usually has something worse waiting, and perhaps nowhere is that clearer than when we discuss black hole mergers, because when giant black holes collide, space-time itself begins ringing. Chapter 13: When Black Holes Collide. One of the greatest scientific discoveries of the 21st century happened in 2015. Humanity detected gravitational waves directly for the first time, tiny distortions in space-time produced by colliding black holes. Einstein predicted these waves a century earlier, and then reality confirmed him. The collision itself happened over 1 billion light-years away. Two black holes spiraled together, merged, released enormous energy, and the fabric of space-time literally vibrated. By the time those waves reached Earth, the distortions were unbelievably tiny, smaller than atomic widths, yet humanity still detected them. That achievement is almost unbelievable. We built instruments sensitive enough to measure distortions in space-time itself, caused by ancient black hole collisions across the universe. Now imagine what would happen if objects on the scale of TON 618 collided. The energy release would become staggering. Entire regions of space-time would shake. The merger would rank among the most violent events possible after the Big Bang itself. And yet most of the energy would not emerge as light. It would emerge as gravity waves, ripples in reality. That phrase sounds poetic, but it is literal. Gravity waves physically stretch and compress space-time as they pass. Your body changes size slightly, distances fluctuate, reality flexes. Normally the effect is absurdly tiny, but near merging black holes the distortions become enormous. This means black holes do not merely sit passively in space, they actively shape the structure of the universe. They collide, merge, grow, launch jets, warp time, distort light, generate gravitational waves. They are among the most dynamic objects in existence. TON 618 almost certainly grew partly through mergers. Over billions of years, galaxies collided, central black, holes spiraled inward, combined into larger systems, each merger increasing mass further, gravity building giants through cosmic violence. And there may be no immediate upper limit. As long as matter and mergers continue, black holes can keep growing. Of course, practical constraints exist. Feeding rates, radiation pressure, galactic environments. But the universe has enormous time available, billions upon billions of years. That patience allows gravity to create monsters. TON 618 is the result of cosmic time operating without mercy, a structure built slowly through collapse, consumption, and merger. And the terrifying part is that black holes grow more efficiently once they become large. A giant black hole exerts immense influence on surrounding matter. Gas clouds spiral inward. Stars become disrupted. Entire systems feed the central monster. At quasar scales, the black hole can outshine galaxies. TON 618 likely consumed extraordinary amounts of matter during its active periods, enough to become visible across billions of light years, enough to announce its existence across cosmic history. And still, despite all this violence, black holes remain strangely simple mathematically. According to classical physics, black holes can largely be described by only a few properties: mass, spin, charge. That simplicity led physicist John Wheeler to famously summarize the idea with the phrase, "Black holes have no hair," meaning they erase almost all detailed information about the matter that formed them. A star, a planet, a civilization, all reduced to the same basic black hole properties. That concept feels emotionally horrifying. Identity disappearing into simplicity, complexity erased by gravity. TON 618 therefore represents not merely destruction, but reduction. The universe compressing enormous complexity into elegant mathematical objects. And perhaps that is why black holes feel philosophically disturbing. They force us to confront how fragile structure really is. Everything familiar can collapse. Stars, worlds, matter, information, even space-time itself. Black holes reveal a universe far less stable than human instincts prefer. And TON 618 sits among the clearest examples of that truth. Chapter 14. Could TON 618 destroy the Milky Way? At this point, many people naturally ask another question. Could a black hole this large destroy an entire galaxy? The answer is more subtle than expected. Black holes are powerful, but they are not magical vacuum cleaners devouring everything automatically. Distance still matters enormously. If TON 618 suddenly appeared far outside the Milky Way, our galaxy would not instantly collapse. Galactic stars orbit based on gravitational balance. A distant black hole would influence motion gradually. However, if TON 618 occupied the center of the Milky Way, the galactic environment would change dramatically. The central region could become quasar-like. Radiation levels rise, gas dynamics shift, star formation patterns alter. Nearby stars could experience disruption. The galaxy's core would become far more violent. Yet even then, the Milky Way as a whole might still survive structurally. Galaxies are enormous. Their stars are spread across incredible distances. Direct stellar collisions remain surprisingly rare. That fact often shocks people. Galaxies can literally pass through each other during mergers with relatively few direct star impacts. Space is mostly emptiness. TON 618 therefore influences galaxies primarily through gravity, radiation, and long-term dynamics rather than instant consumption. Still, the environment near such a black hole becomes deeply hostile. Stars can be torn apart by tidal forces. Gas clouds become heated. Relativistic jets can affect intergalactic regions. Entire ecosystems of matter reorganize around the black hole's influence. And if a star wanders too close, the result becomes catastrophic. The star gets stretched, compressed, destroyed. Matter spirals into the accretion disk, a tidal disruption event, one of the brightest explosions in the universe. For a brief time, a dying star can make a dormant black hole blaze with incredible luminosity. TON 618 likely consumed enormous numbers of stars during its growth. Every giant black hole carries a hidden history of destruction. Worlds erased, stars dismantled, matter converted into radiation, gravity feeding endlessly. And because black holes grow stronger as they become larger, ultramassive systems can dominate galactic centers profoundly. Some astronomers even suspect black holes help regulate galaxy evolution itself. Their radiation and jets can influence star formation across huge regions. In other words, black holes are not merely passengers inside galaxies. They may actively shape how galaxies evolve. TON 618 therefore represents not just a giant object, but a gigantic architect of cosmic structure. Its influence likely extends across immense distances, and yet despite all its power, TON 618 still obeys universal laws. It cannot escape entropy forever. It cannot avoid Hawking radiation forever. Even monsters eventually fade. That realization creates a strange emotional shift. Black holes feel eternal because human civilization is brief. But cosmically speaking, even TON 618 is temporary. The universe outlasts everything. And perhaps that is the deepest lesson hidden inside objects like this. Scale destroys permanence. Every structure eventually shrinks against larger spans of space and time. Human lives shrink against civilizations. Civilizations shrink against stars. Stars shrink against galaxies. Galaxies shrink against the cosmic web. And even giant black holes shrink against the age of the future universe. TON 618 feels immortal only because we are small. Reality itself remains larger still. Chapter 15. Whiten 618 feels like cosmic horror. There is a reason black holes dominate science fiction, philosophy, and existential fear. They trigger something ancient in the human mind, not just fear of death, fear of incomprehension. TON 618 feels terrifying because it breaks the emotional assumptions humans carry about reality. We instinctively assume the universe should remain understandable, scaled for us, navigable. But black holes expose how false that assumption is. TON 618 does not merely exceed human size, it exceeds human intuition itself. The numbers involved stop functioning emotionally. Hundreds of billions of kilometers, tens of billions of solar masses, lifespans extending beyond meaningful language. Reality begins feeling abstract, alien, indifferent, and that emotional reaction matters. Because astronomy is not merely the study of objects, it is the study of perspective. The deeper humans investigate the universe, the less central we appear. Earth stopped being the center, then the sun stopped being special. Then the Milky Way became one galaxy among trillions. Now, even giant black holes become only temporary structures inside a larger cosmic web. TON 618 represents another step in that ongoing collapse of human importance. And yet, strangely, this realization does not always create despair. For many people, it creates awe. Because if tiny creatures on a small planet can discover and understand objects like TON 618, then consciousness itself becomes extraordinary. Think about what humanity achieved. A species that evolved hunting animals with sharpened rocks eventually built telescopes capable of detecting quasars billions of light years away. We inferred invisible objects from warped light and mathematical equations. We detected ripples in spacetime. We photographed black hole shadows. That transformation is astonishing. TON 618 therefore symbolizes two things simultaneously: the terrifying scale of the universe and the incredible reach of human intelligence. Both truths exist together. The universe is unimaginably large, but the human mind is somehow capable of investigating it. That tension sits at the heart of astronomy. We are tiny, yet aware, fragile, yet curious, temporary, yet capable of understanding ancient cosmic structures. TON 618 existed long before humanity, yet today, on one small planet orbiting an average star, people can discuss its mass, radius, luminosity, and relativistic effects. That is remarkable, and maybe that is why black holes fascinate us so deeply. They are terrifying, but they are also invitations, challenges thrown at human understanding. Every black hole discovered pushes physics further. Every observation improves our models. Every paradox forces deeper questions. TON 618 is therefore not merely an object hidden in distant space. It is part of humanity's attempt to understand reality itself, a gigantic dark mirror reflecting the limits of our knowledge. And the closer we look into that darkness, the stranger the universe becomes. Because black holes are not the end of mystery, they may only be the beginning. Chapter 16. What happens to light near TON 618? Light is supposed to be the fastest thing in the universe. Nothing outruns it. Nothing escapes it. For human beings, light feels absolute, reliable, fundamental. But black holes force light itself into submission, and near TON 618, that submission becomes extreme. Imagine standing impossibly far away with a perfect telescope aimed toward the black hole. You would not see TON 618 directly. You would see the chaos around it, the warped stars, the glowing accretion disk, the distortion of space-time. The black region at the center would appear less like an object and more like missing reality, a hole cut into existence itself. That darkness exists because the escape velocity inside the event horizon exceeds the speed of light. Every photon emitted inward stays trapped. Every path curves deeper into gravity. And because light defines how humans perceive reality, black holes fundamentally attack perception itself. TON 618 therefore becomes difficult to visualize accurately. Not because the math is impossible, but because human intuition relies on light behaving normally. Near giant black holes, it does not. Gravitational lensing bends light into arcs and rings. Entire galaxies behind the black hole become distorted. The universe appears smeared around the edge, and if you approach close enough, the visual experience would become increasingly surreal. Stars behind you compress into brighter regions. The sky changes shape. Directions lose meaning. The black hole effectively turns the geometry of vision against itself. This is one reason scientists became so excited when the Event Horizon Telescope produced humanity's first black hole image. Technically, it was not a photograph of the black hole itself, it was a photograph of the shadow, the silhouette created by warped light around the event horizon. Even that achievement required combining radio telescopes across Earth into a planet-sized observing system, and that black hole was tiny compared to TON 618. Trying to image ultra-massive black holes across enormous distances becomes extraordinarily difficult. Yet despite those challenges, physics still allows us to infer astonishing details: spin, mass, accretion behavior, jet structures, spectral emissions. Astronomy often works like forensic science. We rarely touch cosmic objects directly. Instead, we reconstruct reality from light, and black holes force us to study what happens when light itself becomes trapped. That irony is beautiful. Humanity understands darkness by studying distortion, and TON 618 may be one of the clearest distortions we have ever found. But light near black holes reveals another terrifying implication. Time and observation become tangled together, because if you watch someone fall toward TON 618, you would never truly see them cross the event horizon. Their image slows, redshifts, dims, eventually fading almost completely. From your perspective, they appear frozen near the edge, yet from their perspective, they continue inward. This disagreement between observers is not illusion. Both perspectives are valid according to relativity. That fact feels deeply wrong to human intuition. We expect reality to possess a single shared timeline. Black holes destroy that assumption. Near TON 618, time itself fractures depending on perspective. And once relativity starts doing that, ordinary concepts like now become unreliable, which means giant black holes are not merely gravitational objects. They are machines that expose the instability of human assumptions about reality. Chapter 17. The Sound of a Black Hole. There is another misconception about space. People often imagine it as silent. Technically, ordinary sound cannot travel through vacuum, so in that sense, space really is silent. But black holes still produce vibrations, oscillations, waves, patterns, and scientists have actually translated some of those patterns into sound. In 2022, researchers released sonifications based on black hole observations. The results sounded eerie, deep, almost unnatural. Not because black holes literally create audible noise in vacuum, but because the underlying frequencies and data can be mapped into sound ranges humans can hear. TON 618 itself likely generates extraordinary turbulence inside its accretion disk. Matter moving at enormous velocities, magnetic fields twisting violently, shock waves propagating through plasma, jets blasting outward. The environment around a quasar is not calm, it is chaos, organized by gravity. And if humans could somehow survive nearby and convert surrounding plasma oscillations into audible frequencies, the experience would probably feel horrifying. Deep roaring structures, electromagnetic violence, rhythmic turbulence, the soundtrack of matter dying. There is something psychologically disturbing about imagining black holes as active environments rather than static objects. Movies often portray them as simple dark spheres. Reality is more complex. TON 618 is not sitting quietly in empty space. It exists inside a gigantic ecosystem of radiation and matter. Entire clouds spiral inward. Stars become disrupted. Magnetic fields accelerate particles close to light speed. Immense energy pours outward, and all of this occurs around an invisible center no information escapes. That combination of violence and silence is part of what makes black holes emotionally compelling. The universe builds gigantic engines around absolute darkness, and because TON 618 is so massive, the scale of that engine becomes almost impossible to exaggerate. Its accretion disk alone could dwarf enormous regions of planetary systems. The heat generated by friction reaches temperatures capable of emitting intense ultraviolet and X-ray radiation. This means quasars become visible across cosmic distances, not because black holes glow, but because matter dies violently around them. Gravity transforms destruction into illumination. Again, the universe behaves poetically without trying, and while the accretion process looks chaotic, the underlying physics remains astonishingly elegant. Angular momentum, relativity, magnetohydrodynamics, thermodynamics, quantum effects. TON 618 represents multiple branches of physics colliding simultaneously. That is why studying black holes matters scientifically. They force different areas of physics into direct interaction. Near ordinary environments, theories can remain comfortably separate. Near black holes, everything overlaps, and when theories overlap, contradictions emerge, which is exactly why physicists suspect black holes may eventually reveal a deeper theory beneath our current understanding. Perhaps quantum gravity, perhaps something even stranger. Whatever the answer becomes, TON 618 sits among the best natural laboratories for finding it. Chapter 18. Could humans ever reach TON 618? Realistically, no, at least not with any technology humanity currently understands. TON 618 lies over 10 billion light-years away. That distance alone is devastating. Light itself requires billions of years to cross it. The fastest human-made spacecraft ever launched would need absurdly longer than the current age of civilization. Even if humanity somehow reached a significant fraction of light speed, the journey would remain monumental. Intergalactic travel is not merely difficult, it borders on impossible under current physics. This is one reason astronomy feels emotionally strange. We can observe extraordinary cosmic objects while remaining permanently separated from them. Humanity may never physically visit a black hole like TON 618. We may only study it remotely. And yet even remote observation changes our understanding profoundly, because black holes reveal truths about space-time impossible to discover on Earth. Still, imagine for a moment that future civilizations solved interstellar travel. Suppose they crossed galaxies, harnessed relativistic propulsion, built artificial habitats capable of surviving extreme radiation. Would TON 618 become a destination? Possibly. Not because it is safe, but because advanced civilizations might find enormous value there. Energy extraction, scientific observation, time dilation, computation. Black holes may eventually become more useful than stars, especially in the distant future of the universe. This leads to one of the strangest ideas in futurism. Some theorists suggest sufficiently advanced civilizations might migrate toward black holes as the cosmos ages. Why? Because stars eventually die. Black holes survive vastly longer. If intelligence persists long enough, it may adapt around the final long-term energy sources available. That possibility transforms black holes from cosmic horror into cosmic infrastructure. TON 618 could theoretically anchor civilizations billions or trillions of years in the future. Again, this sounds like science fiction, but it emerges from real physics. The universe does not care whether ideas feel emotionally comfortable, and black holes repeatedly force humanity into uncomfortable territory. Another unsettling reality is communication delay. Even if humans somehow travelled near TON 618, communication with Earth would become absurd. Messages would require billions of years. Entire civilizations could rise and vanish before replies arrived. The sheer scale of the universe destroys ordinary human concepts of connection. Everything becomes isolated across cosmic distance, and perhaps that is one reason black holes feel lonely. TON 618 exists unimaginably far away. The light we observe today left before Earth even resembled its current form. In a sense, we're not observing TON 618 as it exists now. We're observing an ancient ghost. For all we know, its environment may already look radically different today. That delay applies to almost everything in astronomy. Looking outward means looking backward. The night sky is a time machine, and TON 618 is one of the oldest, most distant monsters humanity has ever identified. That perspective changes the emotional meaning of observation. Astronomy is not merely seeing distant objects, it is archaeology across space-time. Every telescope becomes a machine for studying ancient reality. And TON 618 represents a message from a universe billions of years younger than today. A universe already capable of creating monsters beyond comprehension. Chapter 19. What if you orbited TON 618? Most people assume black holes instantly destroy anything nearby. That is not entirely true. Orbital mechanics still applies. If you remain far enough away, stable orbits are possible. You could theoretically orbit TON 618 safely at sufficient distance. The key phrase is sufficient distance. Because with an ultramassive black hole, safe distance may still exist inside scales larger than our entire solar system. That alone is difficult to process. You could orbit inside regions enormous enough to contain countless planetary systems while still remaining under the black hole's gravitational dominance. Now imagine looking outward from such an orbit. The visual experience would become extraordinary. The accretion disk could dominate the sky. Light bending around the black hole creates warped arcs and glowing distortions. Stars behind the black hole appear duplicated or stretched. Space-time itself becomes visible indirectly through lensing. And then there is time dilation. Suppose a civilization built a station near TON 618. Time on board could pass differently compared to distant observers. Depending on orbital radius and black hole spin, years near the black hole might correspond to vastly longer periods elsewhere. That creates bizarre possibilities. A civilization could theoretically experience the future of the universe more rapidly, not by travelling faster than light, but by exploiting relativistic gravity. Again, black holes behave like natural time machines into the future. This effect becomes especially powerful around rotating black holes. Rotation changes space-time geometry significantly. The black hole drags space-time around itself. Physicists call this frame dragging. Near extreme rotation, the effect becomes enormous. there exists a region outside rotating black holes called the ergosphere. Inside it, spacetime itself rotates so strongly that remaining stationary becomes impossible. Everything gets dragged along. This is one of the strangest predictions in general relativity, space itself moving, not objects through space moving. TON 618 may possess an enormous ergosphere if rapidly rotating. That means entire regions around the black hole could experience dramatic relativistic effects. And this brings us back to an uncomfortable realization. Human intuition about reality evolved under weak gravity and low velocities. Everything about black holes violates those assumptions. Time slows, light bends, space rotates, causality distorts, information becomes problematic. TON 618 therefore feels less like an object and more like a region where the universe reveals its hidden operating system. And the deeper physicists investigate these environments, the stranger the operating system appears. Perhaps space-time is emergent. Perhaps reality is fundamentally informational. Perhaps gravity and quantum mechanics unify through principles we barely understand. Black holes keep pointing toward deeper layers beneath familiar physics. TON 618 simply points louder than most. Chapter 20. The final perspective. At the beginning of this journey, TON 618 was just a number. A strange catalogue name. Another distant astronomical object. But now the scale should feel different. This is not merely a black hole. It is one of the largest gravitational structures humanity has ever identified. A monster with a mass tens of billions of times greater than the Sun. An event horizon larger than planetary systems. A quasar so bright it can outshine galaxies. A structure capable of warping light, time, and space-time itself. And perhaps most importantly, a reminder. A reminder that the universe is under no obligation to feel intuitive. TON 618 exists whether humans emotionally understand it or not. Gravity built it anyway. That may be the most unsettling truth in all of astronomy. Reality is not scaled for comfort. The universe creates structures beyond biological comprehension naturally. Black holes, neutron stars, galaxy clusters, cosmic voids. The deeper we investigate existence, the stranger it becomes. And yet there is something beautiful hidden inside that strangeness. Because despite our smallness, humanity can still understand pieces of it. Tiny conscious creatures evolved on a rocky world and somehow learned enough mathematics to measure invisible monsters across billions of light years. That achievement matters. TON 618 represents the terrifying scale of the cosmos. But it also represents the extraordinary reach of human curiosity. We are small, but not blind. And maybe that combination is what makes astronomy so emotionally powerful. Every discovery simultaneously humbles and elevates us. The universe becomes larger, but our understanding expands with it. TON 618 is terrifying because it exposes how strange reality truly is. But it is also inspiring because humanity noticed. Somewhere in the darkness of space, billions of years ago, matter collapsed. Gravity fed, stars died, galaxies evolved, and a gigantic black hole emerged. Then, billions of years later, on a small planet orbiting an ordinary star, intelligent life looked upward and realized the monster was there. That connection across space and time is extraordinary. And perhaps that is the real meaning of TON 618. Not simply size, not simply destruction, but perspective. A reminder that the universe is vastly larger, older, stranger, and more complex than human instincts ever imagined. And we have only just begun exploring it. Chapter 21. The largest thing you could ever see. Imagine standing somewhere impossibly far away, far beyond galaxies, far beyond local clusters, far enough that entire galactic structures begin looking like dust. Now imagine trying to identify the brightest single objects in the observable universe. Not galaxies, not stars, single objects. Again and again, one category dominates the list. Quasars, feeding supermassive black holes, and TON 618 belongs among the brightest and most extreme of them. That alone should feel deeply unsettling. The brightest objects in the cosmos are often powered by destruction, matter falling inward, stars dying, gas compressing, gravity consuming. The universe creates extraordinary light through catastrophic collapse, and TON 618 may have outshined entire galaxies during its peak activity. Pause for a second and actually process that. Hundreds of billions of stars working together can be rivaled by one feeding black hole. One. That comparison breaks human intuition completely. We instinctively associate brightness with creation, with stars, with fusion. But quasars reveal something stranger. Gravity itself can become brighter than galaxies, not because black holes emit light, but because infalling matter becomes trapped in violent friction before disappearing. The accretion disk around TON 618 may have reached temperatures hotter than many stars, plasma spiraling inward at relativistic speeds, magnetic fields twisting, matter colliding, radiation erupting outward, all surrounding an invisible center, and this creates one of the most haunting visual ideas in astronomy: a perfect darkness surrounded by overwhelming brightness. TON 618 is essentially a cosmic contradiction, an object famous for trapping light becoming associated with some of the brightest phenomena in existence. And the deeper astronomers study quasars, the more uncomfortable the implications become, because giant black holes appear astonishingly early in cosmic history, almost too early. The universe formed around 13.8 billion years ago. TON 618 already existed billions of years ago when the universe was far younger. That means the cosmos built this monster quickly, aggressively, almost recklessly. Standard models struggle to explain that growth comfortably, which means either our understanding of early black hole formation is incomplete, or the universe had mechanisms for building giants faster than expected. Neither option is comforting, and this is a recurring pattern in astronomy. Every time humans think the universe should behave within certain limits, reality finds loopholes. Larger galaxies, earlier stars, hotter explosions, bigger black holes. The cosmos repeatedly humiliates certainty. TON 618 is one of those humiliations, a reminder that nature does not care about human expectations. Gravity simply keeps building, and when given enough matter and enough time, the results become monstrous. But perhaps the strangest aspect of all is this: TON 618 may not even be close to the largest thing the universe can produce. That sentence sounds wrong emotionally. How could something this gigantic not represent the upper limit? Because astronomy has no respect for emotional comfort. And once you compare TON 618 to the largest structures in existence, the black hole begins shrinking again, which means our journey upward through scale is not finished, not even close. Chapter 22. TON 618 versus galaxy clusters. Galaxies feel enormous. The Milky Way alone contains hundreds of billions of stars. Its diameter stretches roughly 100,000 light-years. Light itself needs 100,000 years to cross it. That scale already destroys ordinary human comprehension, yet galaxies rarely exist alone. Gravity gathers them into clusters. Some clusters contain thousands of galaxies bound together, each galaxy containing billions of stars, each star potentially hosting planets. And within some of those galaxies sit supermassive black holes, including monsters like TON 618. Suddenly the hierarchy becomes terrifying. TON 618 can swallow solar systems, yet galaxy clusters contain countless systems larger than imagination. This is one reason astronomy feels emotionally destabilizing. There is always another layer. Every giant structure becomes tiny compared to something larger. Galaxy clusters themselves can span millions of light years. Inside them, galaxies orbit through colossal gravitational environments. Dark matter dominates their mass. Hot plasma fills intergalactic space. Collisions reshape entire systems. And somewhere inside that chaos, black holes continue feeding. The observable universe therefore resembles an ecosystem of nested structures. Planets orbit stars. Stars form galaxies. Galaxies form clusters. Clusters form superclusters. Superclusters form the cosmic web, and every level dwarfs the previous one. TON 618 is gigantic locally. Cosmically, it remains one component inside a far larger architecture. That perspective changes how we emotionally interpret black holes. At first, they feel like ultimate monsters, but eventually you realize they are also products of something even bigger, the universe itself. Gravity building complexity across billions of years. And the deeper we study those structures, the stranger the cosmos appears. Galaxy clusters contain enormous quantities of invisible matter, dark matter. something that interacts gravitationally but barely interacts with light. Humanity still does not know what it is. Think about how absurd that fact is. Most matter in the universe may be invisible and fundamentally unfamiliar. Meanwhile, black holes distort spacetime so violently that even light becomes trapped. Modern astronomy therefore paints a bizarre picture of reality. Invisible matter shaping galaxies, invisible singularities warping time, quantum mechanics governing microscopic probabilities, spacetime itself bending dynamically. The universe increasingly resembles something alien to ordinary intuition. TON 618 sits directly inside that alien landscape, not as an exception, but as one of its clearest consequences. And perhaps that is why black holes feel philosophically disturbing. They expose how incomplete everyday reality really is. Human senses evolved for survival, not truth. We perceive only narrow ranges of light, tiny scales of distance, weak gravitational environments, slow velocities. Black holes expose everything outside those limits: extreme gravity, relativistic effects, quantum paradoxes, invisible structure. TON 618 therefore becomes more than an astronomical object. It becomes evidence that reality is vastly stranger than the world human biology naturally experiences, and once that realization settles in, the night sky never looks normal again. Chapter 23. If TON 618 passed near Earth. This is one of the darkest thought experiments possible. Suppose TON 618 somehow wandered through intergalactic space and approached our region of the universe, not replacing the Sun, not appearing instantly, actually moving toward the Milky Way. What would happen? First, there would be enormous warning time. Black holes do not teleport. Galactic scales are huge. Even catastrophic events unfold over immense periods. Astronomers would detect gravitational disturbances long before the black hole arrived. Star motions shift. Gas clouds distort. Orbits become unstable. The Milky Way's structure gradually changes. Then things become worse. As TON 618 approached the galactic environment, its gravitational influence would begin reorganizing nearby matter. Stars could be ejected from stable orbits, gas clouds compressed, collisions triggered, and if the black hole became active while feeding, radiation levels could rise dramatically. Entire regions of space might become hostile to life. Still, space is enormous. Earth would not instantly fall inward. That misconception matters. Black holes are not magical predators. They obey gravity. Distance remains everything. But eventually, if TON 618 passed sufficiently close, the solar system itself could destabilize. Planetary orbits distort. Comets get scattered. The Oort cloud erupts. Asteroid trajectories change. The outer architecture of the solar system begins collapsing into chaos. And if Earth drifted too near, the consequences become catastrophic. Not necessarily immediate collision. Radiation alone could destroy the biosphere, especially if an accretion disk formed. Quasar environments are unimaginably violent. High-energy particles, X-rays, gamma radiation, relativistic jets. A nearby active ultramassive black hole would transform Earth into a dead world long before actual consumption occurred. But perhaps the most terrifying possibility involves tidal disruption. If Earth wandered too close, gravity differences across the planet could literally tear it apart. Oceans stretch, crust fractures, matter elongates. Eventually the planet becomes a stream of debris spiraling inward, and somewhere inside the accretion disk the remains of Earth would become light. That idea feels emotionally horrifying. Everything human civilization ever created converted into radiation around a black hole. History reduced to plasma. But even this nightmare reveals something important. TON 618 is dangerous because of scale. Not because it violates physics. Gravity alone can create these outcomes naturally. No exotic weapons, no science fiction magic, just mass, enormous mass, and the universe contains many such dangers. Gamma ray bursts, supernovae, magnetars, rogue planets, asteroid impacts. The cosmos is not designed for biological comfort. Life survives inside temporary windows of stability. TON 618 simply reminds us how fragile those windows really are. Yet somehow, despite all these dangers, life emerged anyway. Consciousness evolved, civilizations formed, and humans became capable of understanding cosmic threats billions of light years away. That transformation may be one of the rarest phenomena in existence, which makes black holes emotionally complicated. They are terrifying, but they also make intelligence feel precious, because against the backdrop of giant indifferent structures like TON 618, awareness itself begins feeling miraculous. Chapter 24, The Mathematics of Terror. Black holes feel frightening emotionally, but beneath the fear lies mathematics. Equations, geometry, tensor calculus, relativity. That may sound less dramatic. It is not. Because mathematics predicted black holes before humanity ever observed them. That fact alone should disturb you. Human beings invented symbolic systems to count objects and measure land. Then eventually those symbols became powerful enough to predict invisible monsters in deep space. Einstein's equations implied black holes naturally. At first, many scientists doubted the solutions represented physical reality. The idea sounded too absurd. Regions where space-time collapses completely. Boundaries light cannot escape. Infinite curvature. But reality kept agreeing with the math. Stars orbited invisible masses. X-ray emissions revealed compact objects. Gravitational waves appeared. Event horizon images emerged. The universe repeatedly confirmed the equations. This is one of the deepest reasons black holes feel philosophically unsettling. Reality itself appears mathematical at fundamental levels. TON 618 exists not because humans imagined it, but because geometry allows it. Gravity follows structure, mass curves space-time, and sufficiently extreme collapse creates horizons. That elegance becomes almost eerie. A simple set of equations describing some of the most horrifying objects imaginable, and those equations reveal another disturbing fact. The universe is shockingly compressible. Stars larger than the Sun can collapse into city-sized neutron stars. Matter itself can be crushed into exotic states. And beyond certain limits, collapse continues until space-time forms an event horizon. TON 618 represents compression taken to cosmic extremes. Tens of billions of solar masses governed inside one gravitational structure. That amount of matter should feel impossible, yet the equations permit it, and once again, reality agrees. This creates a strange emotional contradiction. Black holes appear supernatural emotionally, but mathematically they emerge naturally. No magic required. The universe simply follows its rules, and if enough matter gathers together, giants appear. This realization changes how one thinks about nature. The cosmos does not need intention to create terrifying things. Blind physical laws are sufficient. TON 618 therefore becomes evidence of the sheer power of gravity operating across immense timescales. A monument built by equations, and perhaps that is why theoretical physicists obsess over black holes. They sit exactly where our deepest theories collide. General relativity predicts them. Quantum mechanics destabilizes them. Information paradoxes emerge. Singularities appear. Every path toward deeper physics eventually approaches black holes. TON 618 is not merely large, it is conceptually dense, a single object containing some of the biggest unresolved problems in science. And that makes it more than an astronomical curiosity. It becomes a doorway, a place where humanity's current understanding reaches its edge. Chapter 25. What exists inside the event horizon? This question sounds simple. It is not. What actually exists inside TON 618? The honest answer is brutal. Nobody truly knows. General relativity predicts a singularity, an infinitely compressed region where curvature becomes infinite. But infinities in physics are warning signs. They often indicate incomplete understanding. Most physicists suspect some deeper theory eventually replaces the singularity. Quantum gravity, perhaps. But right now, no complete theory exists. That means the interior of black holes remains one of the greatest unknowns in science. Think carefully about that. Humanity can estimate the mass of a black hole billions of light years away, measure its radiation, study its accretion behavior, even detect space-time waves from black hole collisions. Yet the actual interior remains hidden permanently. The event horizon is not merely a physical barrier, it is an epistemological barrier, a limit on knowledge itself. Nothing escaping means no direct information returns. Reality literally hides regions from the rest of the universe. That concept feels almost mythological. Ancient humans imagined forbidden realms, bottomless abysses, doors separating worlds. modern physics accidentally discovered something emotionally similar, not through mythology, through equations. TON 618 therefore becomes psychologically powerful because it combines scientific rigor with existential mystery. There are regions inside the universe permanently inaccessible, forever, and the deeper physicists examine these regions theoretically, the stranger the possibilities become. Some models suggest singularities may connect to other regions of space-time. Others suggest quantum effects prevent true infinities. Some speculate about baby universes, others argue information remains encoded on horizons. None of these ideas are fully confirmed, but the existence of such theories reveals how unstable our current understanding becomes near black holes. At ordinary scales, physics feels reliable. Near singularities, certainty collapses, and TON 618 represents singularity on one of the largest scales humanity has ever encountered, a gigantic hidden region where known theories stop cooperating. That mystery alone makes black holes scientifically priceless. They are not just dangerous objects, they are cracks in the current model of reality. And every time astronomy discovers larger black holes, those cracks widen, because the universe keeps pushing physics toward more extreme conditions. TON 618 is one of the loudest pushes discovered so far. Chapter 26. The future of TON 618. Everything dies eventually. Stars burn out, galaxies collide, atoms may decay, even black holes evaporate. But the timescales involved with TON 618 are so absurd that human language barely functions around them. The current age of the universe is about 13.8 billion years. That already feels enormous. Civilization occupies only a microscopic fraction of that timeline. Recorded human history becomes essentially invisible. Yet compared to the future lifespan of TON 618, the entire current universe is still young, very young. According to Hawking radiation, black holes slowly lose energy over time. Tiny quantum effects near the event horizon allow gradual evaporation. Small black holes disappear relatively faster. Huge black holes survive incomprehensibly longer. TON 618 belongs in the latter category. It may persist for timescales approaching numbers that human intuition cannot emotionally pass. 10 to the power of 100 years, maybe more, numbers so large they stop behaving like meaningful quantities. If the current age of the universe were reduced to 1 second, TON 618's future lifespan would still stretch beyond imagination. This means the black hole may outlive almost every familiar structure in existence. Stars will stop forming, galaxies drift apart, the cosmos darkens, yet giant black holes may continue floating through cold space long after ordinary stellar life ends. That future is haunting. Imagine a universe where almost all visible light disappears, no bright galaxies nearby, no star-filled skies, only isolated remnants, cold matter, radiation, and black holes. TON 618 could survive deep into that era, a dark gravitational monument persisting while the rest of the cosmos fades, and eventually, after absurd stretches of time, even it evaporates, slowly, almost imperceptibly, quantum effects dismantling one of the largest structures known. That ending feels strangely poetic. Gravity spends billions of years building giants, then unimaginable spans of time slowly erase them. The universe creates complexity and destroys it endlessly. TON 618 therefore becomes part of a much larger cosmic cycle. Formation, growth, consumption, persistence, decay, even monsters remain temporary, and perhaps that realization is oddly comforting. No structure lasts forever, not civilizations, not stars, not galaxies, not even ultramassive black holes. The universe itself evolves continuously. TON 618 simply occupies one chapter in that evolution, a gigantic chapter, but still temporary. Chapter 27. Why humanity will never forget. Black holes. There are many extraordinary objects in astronomy. Neutron stars, magnetars, supernovae, pulsars, exoplanets, galaxies. But black holes occupy a different category psychologically. They feel personal somehow, not because humans interact with them directly, but because they attack our assumptions about reality itself. TON 618 feels horrifying because it forces the human mind into uncomfortable territory, scale beyond comprehension, time beyond intuition, invisible regions beyond knowledge, gravity strong enough to distort causality, light trapped permanently. Black holes expose how fragile ordinary intuition really is, and that makes them unforgettable. They are not merely distant astronomical objects, they are philosophical objects, existential objects, objects that force humans to confront the difference between reality and perception. TON 618 is especially powerful because it combines multiple extremes simultaneously: mass, brightness, distance, age, mystery. It sits near the upper edge of what humanity currently knows about black holes, and perhaps future discoveries will exceed it. That possibility matters, because astronomy has repeatedly shown that the universe is more extreme than expected. Bigger black holes may exist, earlier quasars may exist, unknown structures may exist. Reality rarely stops where humans predict, and that ongoing uncertainty is part of what makes science beautiful. TON 618 is not the end of discovery, it is evidence that discovery never ends. Every answer produces larger questions. How do giant black holes form so early? What happens to information? What replaces singularities? Can quantum gravity resolve the paradoxes? Could advanced civilizations exploit black holes? What hidden giants remain undetected? The deeper we investigate, the more mystery expands, and yet humanity keeps looking. That persistence may be our species' most remarkable trait. We are fragile creatures living briefly on a small planet, yet we insist on understanding the cosmos anyway. TON 618 therefore becomes more than a black hole. It becomes a symbol of that pursuit, a reminder that curiosity can cross billions of light years, even if our bodies never can. Conclusion. At the beginning of this journey, TON 618 was just a strange name, a catalogue number buried somewhere in astronomy. Now it should feel different. This is one of the largest black holes humanity has ever discovered, a structure with tens of billions of solar masses, an event horizon larger than planetary systems, a quasar bright enough to rival galaxies, a distortion in spacetime so extreme that light itself cannot escape. And yet perhaps the most important thing about TON 618 is not its size, it is what it reveals. The universe is not built around human intuition. Reality operates on scales that destroy ordinary comprehension naturally. Black holes exist, galaxy clusters exist, dark matter exists, space-time bends, time slows, light curves, and somewhere in deep cosmic history, gravity assembled one of the greatest monsters ever found. Then, billions of years later, tiny conscious beings on Earth discovered it. That connection is extraordinary. TON 618 reminds us how small humanity is, but it also reminds us how far human understanding can reach. We may never touch a black hole, we may never travel to TON 618, but through mathematics, observation and curiosity, we can still explore it. And perhaps that is the real triumph of science, not conquering the universe, understanding pieces of it, even when those pieces are terrifying. Because ultimately, TON 618 is not just a black hole, it is a mirror reflecting the true scale of existence, a reminder that the cosmos is older, larger, stranger, and more violent than human instincts ever imagined. And somewhere beyond the stars, hidden inside ancient darkness, TON 618 continues waiting silently while the universe evolves around it. Chapter 28. The Scale of Human Insignificance. There is a dangerous side effect to understanding cosmic scale. Once the numbers become real emotionally, ordinary life starts feeling fragile. Human civilization is only a few thousand years old. Agriculture appeared recently compared to Earth's age. Industrial society emerged essentially yesterday. Modern technology is microscopic against cosmic history, and TON 618 existed long before all of it. The light reaching Earth today began travelling across space before the sun fully formed, before Earth cooled, before oceans, before life, before humanity. That timeline is difficult to emotionally survive, because it forces the human brain into a confrontation with irrelevance. TON 618 does not care about human history. Empires rise, languages disappear, civilizations collapse, the black hole remains. This realization can feel depressing initially, but astronomy produces another emotional reaction too: perspective. Human problems often feel overwhelming because our brains evolved inside small social environments. Status, money, conflict fear, all feel enormous locally. Then objects like TON 618 appear. Suddenly entire nations feel temporary. Human history becomes thin. And strangely, that perspective can become liberating, because cosmic scale reveals how absurdly rare consciousness might be. The universe is gigantic, mostly hostile, mostly empty. Yet somewhere on one small planet, matter became self-aware enough to investigate the cosmos. That transformation is extraordinary. TON 618 therefore creates two emotional effects simultaneously. It humbles humanity and elevates consciousness. We are tiny physically, but mentally we can still reach across billions of light years. That duality sits at the heart of astronomy. The more insignificant humans become physically, the more remarkable awareness itself appears. A giant black hole cannot wonder about the universe. TON 618 cannot feel awe. It cannot ask questions. It cannot study stars. But humans can. That may matter more than scale. And perhaps that is why people become obsessed with black holes. They force existential reflection automatically, not because scientists deliberately attach philosophy to them, but because the implications emerge naturally. TON 618 is so large that it destabilizes ordinary thinking. Once your brain genuinely processes that entire solar systems vanish inside its event horizon, daily reality feels temporarily unreal. And that reaction is rational. Human intuition was never designed for cosmic truth. We evolved for survival, not understanding. Black holes expose that mismatch brutally. Yet somehow, against all probability, the human species keeps learning anyway. And perhaps the strangest thing of all is that the universe itself becomes more beautiful the less human-centered it appears. TON 618 is terrifying, but it is also magnificent. A gigantic structure built entirely by natural law, gravity-writing architecture across billions of years. And somewhere in that realization sits one of science's greatest emotional rewards. Reality is stranger than imagination. Chapter 29. Could TON 618 already be dead? This question sounds strange initially. How could a black hole die if it survives for unimaginable timescales? But the question is not really about the black hole itself. It is about observation. Remember, TON 618 is over 10 billion light-years away. That means the light we observe today left the quasar billions of years ago. We are seeing ancient history, not the present. For all we know, the environment around TON 618 may already look dramatically different today. Its quasar activity may have faded, its accretion rate may have changed, its surrounding galaxy may have evolved, mergers may have occurred, jets may have shifted, entire structures around it may already be unrecognizable. This delay applies to everything in astronomy. The night sky is fundamentally delayed information. When you look at the sun, you see it as it existed 8 minutes ago. When you look at nearby stars, you see years into the past. Distant galaxies show millions of years. Quasars like TON 618 reveal ancient cosmic history. Astronomy therefore becomes a strange form of time travel. Not physical travel, observational travel. Telescopes allow humanity to look backward through space-time, and because light speed is finite, the farther outward we look, the younger the universe appears. TON 618 belongs to an era when the cosmos itself looked different. Galaxies were younger, star formation rates differed, black holes fed aggressively. The universe was denser, more chaotic, more active. That perspective changes the emotional meaning of distant objects. TON 618 is not just far away, it is ancient, a surviving signal from deep cosmic history. And this leads to another uncomfortable realization. Humanity's entire existence occupies a microscopic sliver of cosmic time. If the age of the universe were compressed into one calendar year, human civilization appears in the final seconds before midnight. Everything we have ever known exists near the edge of the timeline. TON 618 existed long before us, and likely continues existing long after we observe it. That timescale can feel emotionally crushing, but it also creates wonder, because despite the delays, despite the distance, despite the absurd scale, humanity still learned the black hole was there. Tiny beings on Earth reconstructed one of the largest structures known from faint ancient light. That achievement borders on unbelievable, and perhaps that is the hidden story behind every giant cosmic object. Not merely the object itself, but the astonishing fact that humans discovered it at all. Chapter 30. The most terrifying part of black holes. Most people assume the terrifying aspect of black holes is destruction, being swallowed, spaghettification, the singularity. But the deepest horror may actually be something else. Inevitability. Inside the event horizon, the future becomes one-directional. That statement sounds abstract until you unpack it carefully. Outside a black hole, you can choose directions: forward, backward, left, right. You possess freedom of motion through space. Inside the event horizon, the geometry changes. Moving toward the singularity becomes unavoidable. Not difficult, unavoidable. The singularity effectively occupies your future the same way tomorrow normally does. You cannot stop it. You cannot orbit around it indefinitely. You cannot decide otherwise. Spacetime itself forces the outcome. That idea feels philosophically horrifying because it attacks human assumptions about freedom. And TON 618 amplifies the concept to unimaginable scales. An entire region larger than solar systems where every path points inward. No escape, ever. Even light fails. This is why physicists often describe event horizons geometrically rather than physically. The terror is built into space-time structure itself. Black holes are not giant mouths eating matter. They are regions where the architecture of reality changes, and once relativity starts altering causality itself, ordinary language begins failing. This is one reason black holes appear constantly in existential fiction. They embody inevitability mathematically, and mathematics feels colder than mythology. A monster choosing to destroy you is frightening. Reality structurally requiring destruction feels worse. TON 618 therefore represents one of the purest examples of cosmic indifference imaginable. No anger, no intention, no malice, just gravity following equations, and somehow that emotional neutrality makes black holes even more disturbing. The universe does not hate you. It simply does not care. Gravity will collapse stars regardless. Black holes will form regardless. Galaxies will collide regardless. TON 618 exists because physical law allows it. Nothing more, nothing less. Yet strangely, many scientists find comfort in that indifference, because it means the universe operates consistently, predictably, through discoverable rules. Even terrifying things follow structure. That consistency is why science works at all. TON 618 obeys equations. Relativity predicts its behavior, physics explains its environment, and although mysteries remain, the universe is still understandable enough for investigation. That balance between terror and comprehension may be why black holes fascinate humanity endlessly. They sit exactly at the border between knowledge and mystery. Chapter 31. What if you tried to photograph TON 618 up close? Imagine somehow surviving near TON 618 with advanced technology. What kind of image could you actually capture? The answer is complicated because black holes destroy ordinary photography. Cameras depend on light travelling predictably. Near giant black holes, light paths curve violently. Perspective itself becomes unstable. Suppose you positioned a spacecraft near the accretion disk. The sky would not behave normally. Stars behind the black hole would appear warped around the event horizon. Some would appear duplicated, others stretched into arcs. The accretion disk might seem visible both above and below the black hole simultaneously because light bends around it. This is not artistic exaggeration. General relativity genuinely predicts these distortions. Black holes turn space-time into optical machinery. And because TON 618 is so enormous, the scale of those visual effects becomes overwhelming. A proper close-range image would likely appear almost unreal. A dark central void, a glowing ring of distorted plasma, warped stars smeared around the edges, immense brightness surrounding perfect darkness. And perhaps the strangest aspect is that the black hole itself remains invisible. Every image humanity captures of black holes is technically indirect. We see the consequences, not the object. That detail matters philosophically. Some of the most important structures in the universe cannot be observed directly, only inferred. Science therefore becomes an investigation of shadows, and TON 618 may cast one of the largest shadows known. This indirect observation is common throughout modern physics. Dark matter remains unseen. Quantum fields remain abstract. gravity itself has no direct particle conformation yet. Much of science involves reconstructing invisible causes from visible effects. Black holes represent that process at its most dramatic. Humanity discovered invisible monsters through warped light and mathematics. That sentence still sounds fictional, yet it is real, and if future telescopes improve sufficiently, humanity may eventually capture far more detailed images of ultra-massive black holes, perhaps even movies showing accretion dynamics in real time. That possibility is extraordinary. The species that once feared eclipses may eventually observe relativistic plasma orbiting event horizons across billions of light years. Again, black holes reveal not only cosmic scale, but human progress. TON 618 feels terrifying, partly because humanity became intelligent enough to recognize what it is. Chapter 32. Could TON 618 contain entire civilizations? This question sounds ridiculous initially, but scale changes everything. TON 618's event horizon is so enormous that countless planetary systems could fit inside it. That statement should genuinely disturb you. Our solar system feels huge, yet compared to TON 618, it becomes small enough to disappear within the boundary itself. So theoretically, could civilizations exist inside the event horizon? Technically, once inside, no signal escapes outward, but locally, physics near the outer regions of a giant black hole may not immediately appear catastrophic, especially for ultramassive systems where tidal forces near the horizon remain weaker. This creates bizarre theoretical scenarios. An observer crossing the horizon might survive temporarily without immediately noticing anything dramatic. Of course, deeper inward collapse remains inevitable, but the idea itself feels surreal. Entire worlds crossing a boundary beyond which communication with the rest of the universe becomes impossible. Black holes therefore create natural isolation zones, regions permanently disconnected from outside observers. That concept has enormous implications for speculative cosmology. Some theorists even wonder whether black holes could hide entire internal structures inaccessible externally. Others speculate about quantum information storage, or holographic descriptions. Again, these remain highly theoretical. But the fact that modern physics seriously entertains such ideas shows how profoundly strange black holes really are. TON 618 does not merely challenge astronomy, it challenges ordinary ontology. What counts as observable reality? What counts as information? Can regions of spacetime become permanently hidden? Could entire histories disappear behind horizons? Black holes force these questions naturally. And the larger the black hole becomes, the more emotionally overwhelming the questions feel. TON 618 essentially creates a region larger than planetary systems where the rest of the universe loses access permanently. That sentence alone sounds like cosmic horror, yet it emerges directly from accepted physics. No fantasy required. This is why black holes occupy such a unique place in science. Most astronomical objects extend human understanding gradually. Black holes destabilize it completely. And ultramassive systems like TON 618 push that destabilization to the limit. Chapter 33. Humanity's Future. Under the Stars. One day, human civilization may disappear. That possibility is uncomfortable, but realistically, no species lasts forever. Civilizations rise, collapse, transform, planets change, stars evolve. Nothing biological remains permanent, yet the knowledge humanity discovered may survive longer than humanity itself. Equations, observations, astronomy, the understanding of black holes, that intellectual inheritance matters because it represents consciousness learning about the universe. TON 618 may continue existing for incomprehensible spans of time, but the fact humans recognized it all becomes part of cosmic history. Somewhere in the universe, for a brief moment, matter became aware enough to map giant black holes. That may be one of the rarest events imaginable, and perhaps future civilizations, human or otherwise, will continue the investigation. Future telescopes may reveal even larger black holes. Future physics may finally unify relativity and quantum mechanics. Future intelligence may learn what truly exists inside event horizons. Or perhaps some mysteries remain permanent. Maybe black holes always preserve unreachable regions. Maybe singularities remain fundamentally inaccessible. The universe does not guarantee complete understanding, but humanity keeps trying anyway. That persistence is extraordinary, TON 618, therefore symbolizes more than cosmic scale. It symbolizes curiosity confronting the unknown, a species looking into darkness and refusing to stop asking questions. And perhaps that is ultimately the real story behind black holes, not destruction, discovery. Because every terrifying fact about TON 618 also represents a triumph of human knowledge. We learned its mass, its distance, its luminosity, its environment, its implications, all from one small planet orbiting an ordinary star. That achievement deserves genuine awe, and the deeper humanity investigates reality, the more astonishing existence appears. TON 618 is terrifying, but it's also proof that the universe is richer, stranger, and more beautiful than ordinary life suggests. And somewhere in deep space, while galaxies evolve and stars die, the black hole continues waiting silently. A gigantic reminder that reality extends far beyond the limits of human intuition.